cases. And what I'm going to do now to close the session, it's perform a machine learning bit or a regression on those models. So just to complete the session, let me create a new book. So I'm going to create a book called Machine Learning. And this is where we're going to use a bit of scikit-learn to get the to relate or to generate a linear regression first, and then a decision tree later on based on the simulation results. So for that, there are quite a few libraries that we can use. And see. So we're going to use scikit-learn. And in scikit-learn, you have linear models. Linear model? No? What's happening? Oh, scikit-learn dot linear model. And I'm going to import linear regressions. What? Oh, I'm tired already. So I'm pretty sure you're tired as well. Let's finish this with a high bit of linear regression on the decision tree. Okay, now usually when you're doing a machine learning, you want to split your test data or your data into a train set and test set. I'm going to use the libraries to split the data, but I'm actually going to put 100% of the data into a train set, because for experimental design, there is not so much data that we have available at the moment. There is something that we have added at the end, and probably we can enhance a bit of the model at the end. But let's use this linear regression. And I'm going to use, as I mentioned, there is this model selection, and there is the possibility to split your data into a train and test data. Because in machine learning, of course, we want to train a model with a set of information, but we want to do a blind test with data that has not been used for the training. And there are a lot of aspects that I'm not going to go through, like underfitting, overfitting, bias, variance on your forecast, but or your prediction on the machine learning algorithm that you're using. But I'm not going to go through those details in this session. But we want to use pandas as well. Let me import pandas, because we want to read those results back. And at some point, we also want to plot very quickly the quality of the model. Right? So one thing that we haven't done from when we generated the simulation cases was to export these models. So one way to do it, as you may know, because we would like to have those models later on for, we would like to have this matrix later on for machine learning. And we can use same pandas here. We could have done something like, this is 2 CSV. And we could have written this file to a CSV. Yeah, and I think we have it there. Oh, sorry, let me put .csv. Yeah, so we could have that sensitivity matrix in a CSV. So what I'm going to do, it's exactly that on the machine learning. I'm going to import the files that I used previously. So I'm going to use the input data frame. I'm going to read the CSV. And I know that my location, it's actually very far away from here. I believe is, I need to go out. Need to go out 1 and 2 folders, then go into Norm, then go into Python, and then load my data frame, DOE, lighting hypercube sampling. And in fact, let me put it in here so you have it. Obviously, you need to have this, these two data frames when you're running your own experiments, all these experiments by yourself. So let me put it in Norm session. Reservoir simulation, Norm, Python. Let me copy this Norm session, paste. So now I'm going to bring that data frame that this is the actual simulation cases that I run, that I'm showing here, and I'm showing the input data here. That's just purely input data. That's lighting hypercube sampling 1. And if I show you that matrix, that's the matrix that I generated previously with all the sensitivities that I generated previously. And as you can see, there is a column here that I probably need to delete. And I'm going to delete it quickly with this command. Just drop the column on name. And if I say it again, there we don't have that column anymore. And the other thing that I want to read, it's the output of this, the output from the simulation cases. So, which is this one in here. So again, I'm just going to copy or just write output data frame is equal to id dot read CSV, and I'm going to read that simulation case. And if I put the output df, so here we have a data frame with the output, so we have an input. And now let's do all the machine learning that we want to do. So this is a machine learning section. And the first thing that you would like to do is use your train test split. You want to give input data. So all this data frame is your input, and you want to give what is it that you want to forecast on. In this case, I want to use only one well, and I want to see the quality of the water cut on only one well. So let's say this is a output for ML, and I want to see this case. No. I want to see this, and I want to see the item. I want to bring only, and let's put here, well. Here. So later on, I can run it again and again, multiple times. Let's put it well here and call it E 3, C, H. Okay. And in fact, that I'm going to put this in a function. As filter output ML, and I'm going to pass the data frame, and I'm going to pass the name of the well. So if I do that, in the machine learning section, I want to filter this by well, and I want to filter also by vector. I want to filter by water cut, by such well, or water production, and such other well. And that's going to be quite useful. So I want to filter by this variable and by this other variable, which is called vector. It's called vector here, and it's called vector in the function. Okay, and that is my output, and this is what I'm going to return. So every time that I want to change the name of a well, I just call that little function. Okay. Right. So let's call that function. And this call it df_ml. And if I return df_ml for this well, and I'm going to use this output, output df, output df. The well name is this well, and the vector that I want to check now is a water cut. Equal. There we go. So we have water cut, case 0, 1, 2, 3, 4, 5, and so on. Okay, Jico has a question. It would be interesting to reproduce this project on their own other field data in this modules reader. Can we push it to GitHub? We're great. Okay, see you, Jico. Yes, I saw Jico saying. I know it's quite late for most of you. So what we would like to do now with this output, I would like to take only the objective function root mean square error. Yeah, I want to take just that, and that's going to be my if that is going to be my output or the predictor. Okay, so this is what I want to train on. Why train? That's what I want to train my model on. Now going back to the train split, and I want to pass. This is the input. This is the output. And as I mentioned, the test size, it's 0. I'm not going to split this into training data and test data. Everything is going to be just purely train data. So I have X train, X test. We'll see in a bit that X test should be nothing. Y train, Y test. And if I run that, and if I check what I have in X test, as I mentioned, shouldn't have anything. It's an empty data frame. So all the variables are here. Yeah. So I just did that step because I'm not, this step is not necessary, but if I do want to change this, and I want to take 10% of the data into test, which in fact we can do, because it's not a big data, let's take 20% of the data out. And let's see what we have in X test. We have some cases that were removed. And if we have in X train, we have some cases that we're testing. We're not testing all the cases. Okay. So that's going to be interesting now. So now let's generate our model, the linear regression model to start. It's going to be a linear regression. And the model is going to be fit using the X train data. And I'm going to train it by doing a regression on this input on in this case, remember that we took as the output the water cut objective function of this particular well. So that's my fit. The model has been fit. And let's see how bad or good is that prediction. So at the moment, I haven't done any prediction. So if I want to predict inside the linear regression model, there is a predict function, which I can take, for instance, the test data, or let's take the same train data. Let's say I'm going to take the same train data, and I'm going to call it Y predict train. Okay. Get in there. And this is a first plot. I'm going to compare how bad is that fit. This is going to be quite bad. If we have the original data and we have the prediction that the model is giving us, let's go predict train. So well, it's quite. So if we put a curve or a line of 45 degrees, it should be a straight line going across those points. Obviously, it's not the greatest of the matches, yes. And of course, if we even try to do the same for now, let's do the same for the test data. This might be even worse. Let's try to do it for the test data. Oops. Let's try to generate a second plot with test data. Okay, not so bad, but it's not really great. Now let's see if we can use another. Let's say, well, some people don't call linear regression a machine learning technique, but let's for the purpose of the session, since I scikit-learn as a machine learning technique, let's go to a decision tree. Let's try to do a decision tree and see what we can do with a decision tree. For decision trees from scikit-learn, there is you can import a tree, and it is a decision regressor. Classifier, it's when you have things, when you are predicting on things that are like phases in a well. You have given phases, categorical data. So classification, it's a classification technique. So we're going to use a regressor. And I'm going to call this regressor V3 and decision tree regressor. And it's the same process. So I have a fit. The only difference is that, or I think the only difference not, if you go into a linear regression and you span this, you have many more options. Likewise, if you go into a decision tree, I can fit this. And but you have quite few options. One of those options is what is the number of layers that you have in your decision tree. So it's good to have a limited amount of layers because the decision trees are super good. Actually, just for the sake of exercise, let me show you this. Decision trees are amazingly great on predicting, on training data. But it's very dangerous to, so I'm going to take the decision tree. I'm going to predict now. And you see now this is perfect. That's great. We have a perfect prediction. The problem is if I do the same now I'm going to try to use the same decision tree to test to predict on the test data. Ooh, that's not that good. Okay. So what's happening here? It's that I use certain training set. Decision trees are super good at going into the little categories of the data and splitting the data in a way that you get what is called an overfit model. It's a model that is perfect for your data, but when you test with a different data, it doesn't work. So what you'd like to do with decision trees, it's what is called prune the tree. Prune or let's say it's almost like cutting the tree. I'm going to import some functionalities for you to see more or less what I'm talking about here, and this is just for visualizing. Just don't worry too much about what's going on in here. It's oops, yeah. Well, have a look at that. So it's a massive tree, which is if you see the image here, what it's doing is taking every variable. In this case, it seems that the multi-FLTE variable, it's high importance, and it's splitting the data into parts of data. If it's less than 0.008, it's true. If it's more than 0.008, it's false, and it goes into this. And then it keeps splitting data based on all these values that you see here, all these features or all these input variables. But the problem with this is that it's really overfitting the data, and as you can see, it's almost like a perfect case. And we don't want that. What we want, it's probably cut a bit the tree. Let's say this is my new decision tree, and this is a decision tree that is going to be prune, or let's say you're going to cut a bit the tree to have less layers, and you will see exactly what I mean in a bit. And I'm going to put the maximum depth of this tree is equal to 3. Okay, this is a decision tree prune, and sorry. This is my decision tree prune. What I'm going to do is run this again. And this is on the prune tree. And let's see what happens there. Okay, so not great, but not so bad. No, it's more or less aligned. And the next thing that I can do, it's probably and if you want to have a look at how the decision tree looks like. Oops. What happened there? A list object as, okay, I think I missed that. Oh, that's date. So this is how it looks now. It has 5 levels, 1, 2, 3. Well, I put 5 or 3. I think I put 3. Yeah, I put 3. It has 3 levels only. Yeah. might not be the greatest for the fit, but it's not actually overfitting the data. So you see all the blue points are not super aligned. So you have the orange points, which are the test data, that those are the blind points that are sort of all right. And the next one that I can do, it's increase a bit more the depth of this decision tree. And I'm going to go into a depth of 5. Look at that. So that's a bit better. Still, I'm overfitting here. And I guess the message that we can use here to conclude the session is we probably need to run some more cases. And that was my intention. I run these cases, but I have many more cases that I have added. And unfortunately, the session, it's gone way beyond what I thought this was going to be. But you can see the power of now the full workflow using now from the simulation model up to machine learning, what you could do it in Python. And what's happening here with the decision trees, by adding probably more simulation cases to the mix, we can improve the quality of these models. And when we do the blind test, we can probably get a much better decision tree or shape. And I guess the last one is to show that tree with 5 levels. And that is it. So we have 1, 2, 3, 4, 5 levels in that decision tree. Well, bit of a long session. Questions, comments?
Yeah, hello, Alejandro.
Yes, Felix. Hi.
Yeah, hi, how are you? Very nice presentation. I would like to do just a couple of questions about the random forest, the tree regression.
Yeah.
So, in order to avoid this overfitting, because I was reading a little the documentation, and I saw that regression trees and trees regressors have this tendency to overfit the model.
Yeah.
So, what will be the criteria to select the right max depth and the estimators if we are working with a random forest?
Yeah. So here, okay, we have only one tree. So just for everyone, the random forest, when we're running random forest, we don't have one tree. We have many trees underneath. And in this particular case, there is an algorithm that it's called CART, and that is deciding where to put and optimizing something that is optimizing a criteria. So something that I didn't explain here is when I generated tree, yeah, seems like magic, but there are a few things that you should do here that you could set. And one of the things that you should do, it's again, so you should have your random state set. And the other thing, it's I think the criteria. This is the criterion. Should be the criterion. Don't know why it's not coming, but you can have either Gini or entropy to decide what is your what is the criteria on this decision tree, right? Now, when you run random forest, in every split, the variables that you are selecting, rather than selecting reducing the Gini value here, or the entropy, in this case is a MSE, is the criteria. What you're trying to do, it's randomly selecting these variables, and the sort of theory in random forest is that the models are not perfect. They say they are not the greatest models as individuals, but if you have many models, It's almost like the collective knowledge of many models, even if they are not perfectly right, and they are 90% right, 90% of the time right, then what you get is a more accurate prediction when you add all those models. Now, the random forest, there are a few things that you can do. You can do bagging, you can do boosting, or you can do random forest. So let's see if we can do a random forest very quickly here. Okay, and I think from sklearn, dot question, where is a random forest? Just let me remember. I think it's ensemble. It's an ensemble technique. Ensemble import random forest regressor. Right. So what you want with random forest is if you have 14 features, you want to have something in the middle. So let me show you what I mean with that. So this is a random forest, and it's equal to random forest regressor. And if I go into the options, let me run the option. Let me run this. Yes, and I think one thing that that you need to consider, it's setting a value that it's not your minimum amount of features. When I mean the features, in this case we have 14 features, right? As you can see, the less in the decision tree, the less amount of depth that I have, or let's say these are the top of the features, the weaker the tree. So we want to use something that it's probably not using all of them, but using something in the middle. If we have 14, let's not use 14, let's use probably 10. So how you select that, and I'll show you what I have done to select. Let me just remember just how it. Okay. So let's say we have my number of estimators, which is a number of trees. I want to have 50 trees. And as usual, let me check the random state to whatever number. And this is the maximum features that I want to have in every tree. I want to have, let's say, 4. Let's say something in the middle between 3 and 14. Let's put 7. Okay. So that random forest classifier, I'm going to train the random forest with the X train again and the Y train, and okay, there you have the random forest. One thing that you should use is a way to do scoring. Let me follow the same thing here. I'm just going to do this plot. But now I'm using the random forest classifier, the random forest regression, RF, predicting on these two. Yeah. So you have, we have some problems with this, and I think we've always have some problems with this. Now, if you really want to improve your criteria, you should use some metrics. So if you go into a scikit-learn, it brings you some metrics And let's say, oh, what can we import here? I don't know. I don't know what I think. I think the I'm not quite sure what we can. I think there is a score. Let me see, just a second. There is a score on the model, or the model itself. I think there is a model score. I think if I do rf dot score, let's say I do the score if I do the score based on the training data, 92% accuracy. As you can see, it's very accurate. If I do the score on the test data, that's 45% accuracy. That's very, very bad. Hi, Roman. No, I haven't. There is something that I have found that I would like to explore. Really, I think was it you? I think you published something. But yeah, I've seen something on reinforcement learning. There is an example there in the published in GitHub, and I'm very keen to review that, but I haven't seen that. Just to finish this because it's a very interesting question. Let's say you want to optimize this. What I would do is let's put this in a loop. Let's call it for I in range. And let's say call it, I'm going to run 10 times this loop. And I'm going to iterate and get some sort of a score for every time I go to a loop. I want to score my test, right? So I want to sort of score test dot append, and I want to store the score of a random forest. And I want to run, let's call it 5 times. My estimators, I want to run from 5, 10, 20, 30, 40, and 50. My features, this is 3. Just increasing slowly one and the other at the same time. 10, 12, and full features. And in this case, I'm actually reporting the score of the features. The score of the test data. So this is my I, and this is a features I. And I probably want to also get a name of a case. And the name will be, let's call it names append, and this is a estimator plus estimator subtype plus underscore, let's put here something like underscore feature, and let's put here features subtype, and I probably need to put here a string, convert this to string. Okay. So if I do that, I have the score test. So this is going to run for a bit. Oops, I have a plots there. I shouldn't have had the plots, sorry. But what I'm trying to do is get a matrix where I sort of do PLT dot. I think this should be like a bar where I do what is X? It's names, and then I do score test. Yeah, and I think you see where I'm getting, Felix. I'm trying to do a bit of iteration where I see how my score is getting better with my estimators and my number of features. Sorry if that answer was a bit too long.
No, thanks. That is exactly what I was looking for. So in summarize, there is the relation between the number of features and the number of estimators that you are getting.
Not really. You can do the combine. It's just that for the quick example, I did it like that. But you can test it like that with the same number of features, and you can do quite a combination of those.
Okay,
and,
so I can use this for loop to test these combinations.
Yeah, exactly.
Okay.
Exactly.
Okay, thank you so much, Alejandro.